Okay, for the hands-on part of the lab, ordinarily you guys would be putting your hands on things and actually measuring them, but you'd be in a group and you'd be helping each other out and you'd be looking at each other's measurements to make sure that you knew what you were doing. So you're incapacitated and I'm gonna be the lab partner that's actually measuring everything. But I'm going to be showing you the measurements and you need to be able to read the instruments and write down what we're measuring. If you look at your tables, remember there's a table that's part of the lab, and if you don't have a table, now's the time to pause this and go get the table. And also the questions. You have a list that says conversions, and what we're gonna do is we're gonna go through one by one and measure everything in English units, which would be inches or ounces, or the other kind of ounces, or Fahrenheit degrees. And we've got a far column that's the measurement in SI units. That would be centimeters or milliliters or Celsius degrees or grams. The middle columns you're gonna fill in on your own, but both middle columns start from the English column, the first column that you took. So I guess from your orientation, be on this side. So you convert inches to centimeters or ounces to milliliters or to grams, depending on what you've measured. So we're gonna fill in the two outside columns, you're gonna fill in the two inside columns. Both of those conversions are in your lab, in the materials. There's a column for ballparks. What's a ballpark? A ballpark is a rough estimate. If you just have rough conversions in your head, then unless you're doing precise lab work, you can pretty much do a quick, oh, okay. Like somebody gets stopped, the car gets stopped and you see on the news that they had 20 kilos of something they weren't supposed to have in their car. And you go, wow, that seems like a lot. Well, if you know a kilo is about 2¼ pounds, then you know, geez, that was almost 50 pounds or whatever it is they had. That's a ballpark. It turns out that a foot is about 30 centimeters long. A gram is, an ounce is about 30 grams. A liquid ounce is about 30 milliliters. Now, when you look at the precise conversions, none of them are exactly 30, but they all kind of round off to 30. So 30 is a useful ballpark to have in your head. Temperature is a little trickier, is because here's the 0 point in Celsius and here's the 0 point in Fahrenheit. You can't just go on the fact that Celsius degrees are about twice as big as a Fahrenheit degree. You have to work your way off of a crossover point, like 0 to 32, right? 0 in Celsius is freezing, 32 is Fahrenheit. And there's a couple of others, because it isn't exactly a 2-to-1 ratio, if that's the only crossover point you use, the farther away you get, the farther off you're gonna be. So, and this is all in the lab. The other natural crossover point is the old physics room temperature that is 25 on the Celsius and 78 on the Fahrenheit. Now, it turns out those are not exactly the same temperatures, but it's still, that's crossover. And the other one is body temperature, which we're doing a lot of recently, which is 98.6 on the Fahrenheit side, which it's actually lower than that, but it's 98.6. And 37 on the Celsius side. And again, those are not exactly the same temperatures, but they're close as a ballpark. You have a sheet that says precision conversions. You may have done this in middle school, where you start with one measurement and you put your little calculator down and you do the precision conversions, where an inch is exactly 2.54 centimeters. And an ounce is 28.3. I've forgotten now whether it's grams or milliliters, but and it's 29.5 for the other stuff. That's why it rounds off to 30. So you're gonna fill those two columns in. That's the meat of this part of the lab, because you're not gonna actually be measuring yourself. You're gonna be doing the conversions. So I'm gonna go down the list. Now in the typical lab, you never know what you can get your hands on. So I've left the first column blank for filling in what you're measuring. But since there's nobody fighting me for the equipment, we're gonna go in order down the list of measurements. So we're gonna start with the length of your own left pinky finger. Okay, so this is the length, can you see that? The length of my left pinky finger in inches. Now keep in mind, inches are not metric. Is that this inch is not split into tenths between 2 and 3. It's split into halves and quarters and eighths. So take that into account when you're making this measurement. Okay, now the measurement on the other column is the measurement in centimeters. So see what the tip of my pinky finger lines up with, and just take the nearest big line and put that down for centimeters. When you do the middle columns, you already know roughly what the two measurements are. If you get a number in the middle that doesn't come anywhere near your actual centimeter measurement, you did something wrong. So you have to go back and kind of try to figure out why, because as long as you're reading these things right, is that those two should be pretty much the same measurement, especially for something like this. Okay, so that's the left pinky finger. The next thing is the mass of your keys. Here is a postal scale. It measures in ounces. And here's my keys. I'm going to put that on the scale. And, okay, if you can get down, this is the ounces. So read the number, pretty easy. It lines up right between, well, that's weird. Oh yeah, right between 6 and 8. So that should be a pretty easy one to get. You don't have to, sometimes you have to fudge these things. Is that I always tell people, don't give me a reading you can't actually read. And people go, oh, it's like 6 1/4. Well, no, that wasn't even 6 1/4. Okay, that was ounces. Why we have two different types of ounces measuring two different types of things, I can't tell you. It's the English system. Here's the balance for the metrics. So I'm going to put my keys in the dish here. And you may have run into this at your doctor's office. They move the weights out until it drops. Then you move it back a notch. Always got to be in a notch. You move this out until it drops. Okay, now something's, okay, so here's the dial. There's a little spring in there. Now we want to get this thing to balance. Okay, so we're only going to take this to the nearest gram. This thing actually reads to hundredths of a gram, but we have this lousy spring scale over there, so why would we go to something really precise on this one? So what we have here is 190, and then we take the number that is closest to the 0 here, which would be 2. So that's 192. So I gave you the reading here because I wasn't sure how easy it was going to be to read. So that's grams. Don't give me naked numbers, remember. Everything should have units with it. Okay, the next thing we're going to do is look at temperature. And we're going to do temperature of the room. I have 2 thermometers, a Fahrenheit and a Celsius thermometer. They've been sitting here for a day, so they're reading the temperature of the room. Always hold it, don't hold it by the base. Okay, this is the Fahrenheit thermometer. Read the top of the column. Make sure you know what each one of those cross lines means because they're different on the 2 thermometers. See it well enough?
It's blurry.
Any place, can you move it someplace where it's not so blurry?
I think it's going to be hard for them.
Okay, let me. I think it's because we're both moving. Set that thing down on the table so that it's upright down on the table. So that it's absolutely still. Let's see if this will work. Okay, tilt it a little bit, tilt it. No, towards so you can read it. Not that far in, because now you. Okay, the cross line above is 80, the cross line below is 60. So that line in the middle is 70, and then the little cross lines are 2s. So that's your measurement in Fahrenheit. Here's Celsius. See if I can. Oh, you're up too high. Okay, that cross line is 20. Notice the next line up is 30, so each of these cross lines is just 1 degree. So count the little cross lines to get your reading there. Everybody got it? Okay, I'm gonna move this. Now this is the one that if you were doing this, it would mess you up. And I would tell you the story of my wife, who is holding the camera right now. So since she's holding the camera, I'm gonna tell you the story. Is that you need to do the volume of the jar. Now, once a week, for a long time, my wife would go into the back bathroom and step on the scale, and I'd know she was in there because I could hear her swearing. Now, she never once came out of that bathroom and had me go, so what's your volume this morning? Because that isn't what you measure stepping on a scale. So sometimes people would measure this and they'd fill it with water and do that. That isn't how you do it. Volume is how much water is in here. And the only way to measure that is you must have something you can pour water into to measure it. If you notice, we got a measuring cup. We have a fancy, basically a measuring cup for metric. I'm gonna fill this up to the top. I'll be back in a second. Doesn't have to be exactly to the top because I'm gonna measure whatever water this is, I'm gonna measure it twice the same volume. So we're gonna start with the English measurement. Oops, let me turn it around. Put the on the ounces side. So here's what I mean by not, now that's between 4 and 5. Now you may look and go, oh, it's a little bit more than a half, but you don't really know how to measure that. So the right thing to do is either decide that it's 4.5 or decide that it's 5. I think if it were, you're not looking at the cup anymore.
I know, I'm trying to find it. What did I?
Tilt it that way.
Oh, okay. Oh, no.
If you put it on the paper, find the paper. There we go. So I think I would take that as 4.5. Okay, here's the other thing we're gonna measure in. This fills up to 100 milliliters. So I'm gonna pour the water in. Now that little baby juice jar holds more than 100 milliliters. So I filled it right up to the 100 point and I'm gonna pour that out. I'm gonna put the rest of it in here. Now the question is, what is that in milliliters? So take your reading. If you're off by a milliliter or two, it's not gonna be a big deal because this cup doesn't measure anything very precisely. This measures more precisely. Okay. The next thing on the list, the length of your own right forearm. So this is my right forearm, dressed for the weekend. Now, I always tell people, I don't care how you measure it as long as you measure it the same way twice. So it would be wrong to measure it this way for one and then that way for the other. I have had people measure it right out to the tip of their finger, which is okay, except I look at their labs later and go, I don't remember there being an orangutan in the room. I'm not gonna do that. I'm gonna measure from the crook of my elbow to my wrist. So if you take a look, this is the English measurement, this is inches. So have you all got your readings? Well, of course you can freeze frame this. Now we're gonna go over to the centimeter side and measure the same distance from the crook of my elbow to my wrist. And write that down in the column for actual measurement in SI units. That's centimeters. Let's see. The mass of the English measuring cup. So here's our English measurement, here's our cup. We're putting it down there. Looks like it's almost dead on 2 ounces, right? It's lined up with the 2 pretty well. I'm supposed to be letting you read these things. Put this back down to 0. Put the cup on there. 100 should be a little too much. Now, every ounce is roughly 30 grams, so I knew somewhere around 60 we were going to hit our limit. Okay, so 60, and then we take the number that's closest to this 0. That one should be pretty obvious. And that's your reading in grams for the weight of the English measuring cup when it's empty. So you've got 2 of those measurements. Now, the next thing is to put a half a cup of water in here and then measure it for weight again. Thirds. Okay, that's 1/2 cup. Now we know the cup weighs 2 ounces. Now just read where that yellow line is, and then for the measurement, you're going to subtract the 2 ounces of the cup out from what you're looking at now. So we're going to come back here, put this on the scale, or on the balance rather. See what we get. 100 grams, 200 grams. Okay. Okay, it's not quite in the notch. Okay, so 200 is our first weight, 0 is our second weight, and then the third digit is whatever's closest to the 0, and that should be pretty obvious, is whatever's closest to the 0. And you need to subtract out the, was it 62 grams? You've got it written down. However much you measured for the measurement of the cup mass. Mass and weight are not exactly the same thing if you're a physics person, but we're kind of talking about them like they are the same thing. Okay, the next one is going to be a little tricky. Okay, you get a chance to see how I've taken over the entire lab here. We're going to measure the length of the lab table. Now this is a meter stick, so it's 100 centimeters, and so we can just go 1 meter, 2 meters, 3 meters, each one of these is 100 centimeters, 4 meters, 5 meters. Okay, so come on over here to the end. Okay, we are 5 meters in. Here's the 5 meter mark. Good, I didn't know. I was worried I was going to hit the wall. I'm about 2 centimeters short. Okay, so this is the rest of the measurement. We've got 5 meters to here, and then 10 plus 4 Don't try to figure out what the little lines are. So that is the measurement for SI units. I should have started with English units, but it's easier to do this end to end to end for the SI units. Because here's the problem. This is not a yardstick. This is a meter stick. So if you go with the English units, you wind up with some weird fraction at the end. So what I'm going to do is I'm going to use it as a yardstick 3 feet at a time by measuring to the 36-inch point. So we do the same thing, except I'm not going to do end to end. There's 36 inches, so that's 1 yard. That's 36 inches, that's another yard. That's 36 inches. These are all the papers you've been sending me that I got to correct. There's 36 inches. 1, 2, 3, this is the 4th one. There's 36 inches, that's the 5th one. Okay. So, we had 5 yards, that is 5 times 3 is 15 feet. This is 16 feet. Every foot is 12 inches. That's the fun of the English, you have to remember those numbers. And beyond 16 feet, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 10 more inches. So overall, in order to do the middle columns, you've got to convert that to inches. So make sure you figure out the right total number of inches, the right total number of centimeters, or otherwise you don't have the numbers you can work with to do that measurement. Okay, the next thing, volume of 2 cups of water. Now, most people figure out pretty quickly, you don't need to measure out 2 cups, you just need to measure out 1 cup and then multiply that by 2. Now, the volume of 2 cups of water is, in English units, is 2 cups. But you kind of need to know that a cup is 8 ounces in order to do the math. So 2 cups is 16 ounces, right? Each cup is 8 ounces. So I will fill a cup up. Ooh, dead on. Okay, so this is 8 ounces. Multiplied by 2. May as well do this over here. Let's see how many milliliters this is. You won't need to worry until I get to the end one. Okay, there's 100. Double check. Yep, that's 100. There's another 100. Yep, another 100. That's 200. Let's see if you can get a reading off of that. What's the water line up with the top? See where the 40 and the 50 is. Each one of those lines is 1 milliliter. Let me get the bubble out of there. So that's 200 and that multiplied by 2, because we only measured out 1 cup and the lab asked for 2 cups. So you got to factor the 2 in. Okay, then need you over here. So the next thing is the temperature. Now I put a flask of water in the refrigerator. During the lab, if we were doing this, everybody would be running to the refrigerator to measure it so that it wouldn't heat up too much, because more and more people took it out of the refrigerator to measure it. I'm the only one doing the measuring, so I'm gonna go grab the flask and put it here, and we're gonna take the measurement. So this has been in the refrigerator for a couple of days now. You'll notice there's a little star on your labs. That's because in the lab, every time you measure temperature, you had to take both measurements at the same time. Because of all the things you measured, the only thing that could change during the lab would be temperature, right? As people took this in and out of the refrigerator, it got warmer. As more and more people worked in the room would get warmer. So we're taking both measurements together. Now I'm gonna let these, now these are lab thermometers, so they'll hit their temperature and stall pretty quickly. But I will probably take them out and show them to you so that you can get a better picture of them rather than looking through the flask. Still dropping. When you look at the bonus questions, one of the bonus questions talks about the 2 different temperatures we took and how many calories it would take to, or either to heat up the water from the refrigerator to room temperature, or to cool off the water, how many calories would it lose. But these are the 2 readings that you're gonna use, and they're gonna be the metric, the SI units. Okay, looks like we've got pretty equivalent. Okay, can you read it? Yeah, let me set it down again. I can turn it.
I don't know if it's gonna be readable.
I can't see the screen, so I can't adjust
No.
it to try to help. Oh, you're above the column. You're not shooting it.
Oh.
There we are. Oh wow, it's warmed up quite a bit since we took it out. Okay, here's the problem. Is because I'm standing this up on the table, it's actually reading the table temperature. That's how fast these things react. Okay, here's the Celsius reading. I'm not gonna put it on the table. Let me, you just stay, and I'll try to get it in a position so that you can read it. You just stay. Okay, that's the 0. The next line up is the 10. Every one of those lines is an individual degree. You can see it's already starting to get warmer in the air. It was below the middle line before it started to heat up. Don't move it. Okay, so the cross line with the number next to it, that's a 40. It looks like it's pretty much lined up there. This is your Fahrenheit, your English unit. And you can see it's already starting to get warm. These lab things react pretty fast. So, hope you got your 2 readings there. Okay, the very last thing on the lab is not something I expect you to measure. I don't expect you to get onto Google Earth and get Google to tell you what it is. I just want you to, for the English column, just give me a rough idea of how far you are from here, from school, in miles. And then you're gonna do a ballpark conversion, where a mile is about 1.5 kilometers. And then you're gonna do precise conversion off of the precision conversion list. And you're not gonna fill the last box in because I don't expect you to be able to go out and measure it in kilometers. Most of you don't have kilometers on your car odometers, and you're not supposed to be driving in here anyway. I just wanna use the Wi-Fi. Okay, those are the measurements. The extra credit, the first one is actually a real thing. When I used to teach water systems, we would take my students out, and they would have these little devices that could read how much iron was in it, how much oxygen was in it, and the little devices always read in what are called ppms, parts per million. It's a ratio. So many parts of iron for 1,000,000 parts water. And then we would come back into the lab, and I'd go look those up to see whether they were within normal ranges, and they'd go, well, the stuff in the book has milligrams per liter. We've got ppms. And I said, well, then figure out how to change from one to the other. Milligrams per liter is also a ratio. So you need to know how the 1 to 1,000,000 factors into a milligram per liter of water. And so that goes back to the part 2, where you're doing different units converting different ways. And then the very last one, I already talked about, how many calories does it take to make the water warmer. And you don't have to do the extra credit, but if you want full credit for it, in fact, you want credit for it, show me how you did the work. Which you need to do for part 2, you don't need to do for part 1. When you're going back through the lab, check it, don't give me naked numbers. Any place you got a number, there should be a unit next to it. And I think that's pretty much covers the lab, so you can stop. Thank you, sweetie.
But it's not stopping.
You hit the red thing?
Yes, I did.
It should go to a round.